in this case, we're trying to find the highest common factor of 52 and 28, also known as the greatest common factor. So we're going to do it by using prime factorization trees. So we do it like this. What times what is going to equal 52? So the easy way to start really is, because it's even, we can just go right. 2. 2 times what? 2 times 26. And we then, once we've got the two factors, we then look at those two factors and say, is any of them a prime number? In this case, 2 is a prime number because it can't be divided by anything else except 1 and itself. Once you get to a prime number, circle it. You can't go any further with that number. But 26 is not a prime number. We can go further with 26. It can be divided by 2. And 2 times 13 equals 26. Again, let's look at those two numbers. Are any of them primes? Well, 2 is a prime number, and so is 13. So this tree is now finished. With 28, we know that 7 times 4 is 28. 7 is a prime number, 4 is not. We can keep going with 4. 4 is the product of 2 times 2, and 2 are primes. So we circle them. And now we need to look carefully at both trees. Are there any factors, any prime factors that is, that are shared between both of them? Well, the 7, no, that only appears here. The 13, no, that only appears here. But this 2 has a buddy over here, so we will use a 2. And this 2 and this 2 are buddies, so we know that there's another 2 that are shared between 52 and 28. And we multiply those two prime factors together and we get 4. So what that means is that the highest common factor of 52 and 28 is 4. And that's done.